Okay, let's start with question 1. So for this type of questions where you want to find the SI base units, what I usually do in exam is first I make the thing you want to find the subject. So you move around, you find the subject. Then for clarity's sake, I list down all of the base units one by one. So radius is meters, velocities is meter per second. And we know that F is equal to ma, so force is equals to mass is kg and acceleration is ms -2. And then we sub all these inside here, then we can find the SI base units. kg meter s -2 divided by 6 pi is a constant, so they don't have units, so you can just ignore the 6 pi. And then radius is m times meters per second. And then we cancel this one and this one and this one, so we are left with kg s -1 divided by m. We can move the m back up like so. There, and then we have shown that the SI units of viscosity. So now for part B, the sphere has a radius of 3 cm and is falling vertically downwards at terminal velocity of 2 meters per second through the liquid. The drag force acting on the sphere is 0.096 newtons. So remember to convert cm to negative k, and we just sub the values back into this one we found, then we can find the viscosity. So viscosity equals to the drag force. Drag force is 0.096 newtons divided by 6 pi, and the radius, remember, change it to meters, do not forget, and then times velocity, which is 2, and you press your calculator. You should get 0.0852 SF. Okay, now we have to label the directions of 3 forces acting on the sphere as it falls at terminal velocity through the liquid. So we have 2 upward forces. One is the upthrust, and the other one is the drag force. And the one downwards is the weight of the ball. Right, there we go. Part D. But that's given that the density of the liquid is 920 kg meter per meter cube. Show that upthrust acting on the sphere is 1 newtons. So the formula for upthrust is rho Vg, volume, times gravitational acceleration. Volume of the sphere, we know is 4/3 times pi times r cubed. So the upthrust acting on the sphere will be equal to the density of the liquid, 920, times 4/3 pi radius. We know that the radius from earlier is 3 times 10 to the -2 meters, times the g, which is 9.81. Remember to use 9.81, don't get confused from mechanics. Don't put 10 or you lose the A1 mark, which is 1.0 newtons to SF. Use your calculator. Alright, next one. We have to calculate the mass of the sphere. Okay. So we know that the sphere is in terminal velocity, right? So we should know that in terminal velocity, there's no acceleration, speed is constant, so the resultant force is equals to 0. And when the resultant force is equal to 0, let me show you. the up thrust and the drag force is equal to the weight. If one of these is larger than this one, then the speed of the ball will change and then it's not in terminal velocity anymore. And let's go. So the drag force plus the up thrust is equal to weight, and weight is mg. So 0.096 plus up thrust 1 we found just now equals to m 9.81. So we use a calculator, and then we found out that the mass of the sphere is 0.011 kg. Alright, there we go, we finished question 1. Okay, now for question 2, define displacement from a point. So let me show you that. So this wavy line is the distance, and displacement is the shortest straight line between 2 points. So we can define displacement as shortest distance from a point to another point, or we can follow the mark scheme they gave is distance from a point in a straight line in a given direction. Okay, 1 mark. So part B. An object is projected horizontally at a speed of 6 meters per second from a slope as shown. So before I do, the ball will travel like this, will leave, and will fall back down somewhere here. Alright, and then I would label here as vertical displacement as y and horizontal displacement as x. So determine the horizontal distance traveled by the object. So we want to find the horizontal displacement as x, this one. So we can use the equation Sx equals to u x t plus 1 over 2 ax t squared. So they mentioned that air resistance is negligible, so there's no change in speed in the x direction, so this one will be 0. So we are left with the initial velocity in the horizontal direction, which is 6. So 6 times time 0.71 seconds. Then we get 4.26 meters per second. I mean meters. Sorry, 4.26 meters. So determine the vertical distance traveled by the object. So we want to find Sy. So we can use the equation again. Sy equals to initial velocity y plus 1 over 2 acceleration in the y direction times t time squared. Okay, so the initial velocity of y would be 0, because like if you ignore the horizontal part, it would be just like drop down like that. So Sy equals to 0 plus 1 over 2. Now that we ignore this one and it's dropping down, so the acceleration would be equals to g, and then time. Remember to square this. So the displacement in the y direction would be 2.47 meters or 2.5 meters to SF. Part 3. Use your answers in B1 and B2 to calculate angle theta. Let me sketch. So we found this one to be 2.5 and the horizontal to be displacement to be 4.3, right? So this is the slope. So we know that this is the opposite and we want to find angle theta. This is the adjacent. We can use tangent, which is tangent theta equals to SOHCAHTOA, opposite over hypotenuse. Adjacent, 4.3. And then we use inverse tangent on your calculator, then we get theta to be 30.2 degrees. Determine the magnitude of displacement of the object from its original position, which is the hypotenuse. We can just simply use Pythagoras theorem. So h is equals to square root 4.3 squared plus 2.5 squared, which is equal to 5 meters. So this one is 5. By considering energy, calculate the speed of the object just before it lands. So according to conservation laws, the kinetic energy gain is equals to loss in the gravitational potential energy. So the change in kinetic energy is equals to the final kinetic energy minus initial kinetic energy, and then it's equals to GPE. Okay, so the final KE is 1/2 mass 6 squared. Oh, it's my bad. Minus initial. So initial 1/2 m. Initial is u 6.0 they gave just now, and remember to square equals, so GP is m g change in h. So we can cancel the m and then we can sub in the values. 6 squared equals to 9.81. Change in the height is this 2.5. So you move the values around, we get V is equal to square root 6 squared plus 2, 9.81 times 2.5. Use calculator and then we get V is equal to 9.22 meters per second, or 9.2 meters per second to SF. Oh, let's go. Alright, 11 marks. Next question. Okay, question 3. 3a, state Hooke's law. So we know F equals to kx and k is a constant, so we can say that extension is proportional to the force applied. Okay, B, the variation of the applied force with the extension for a sample of a material is shown in figure 3.1. The sample behaves elastically up to an extension of 80 mm and breaks at point X. On the line figure 3.1, draw a cross to show the limit of proportionality. Label this cross with the letter P. So the limit of proportionality is when the line is no longer straight, so it's around here. So here is a curve, so it's not proportional anymore, so this is P. Okay, now on the line figure in figure 3.1, draw a cross to show the elastic limit. Label this cross with the letter E. So they stated the sample behaves elastically up to an extension of 80 millimeters. So it's here. Okay. Sample in B has cross-sectional area 0.4 millimeters squared and an initial length of 3.2 meters. For deformations within the limit of proportionality of the sample, determine the spring constant. Okay, so since it's proportional, so the spring constant will be equal to the gradient of the graph. So we choose any good points, for example this one, or we just choose this one. You can choose P, which is 60, and the X is, the Y is 5.4, and then we can use 0, 0 for easy calculation. K is equals to the change in Y over change in X. Remember, we have to change 60 millimeters to meters, which is -6 because of the square. Oh, it's not squared, so it's -3. Let me pull out a calculator. So 5.4 divided by 60 times 10 to the -3 is 90 newtons. It's 90. Now we have to find the Young modulus of the material from which the sample is made. So the Young modulus is equal to stress over strain, and stress is equal to the force applied per area divided by the extension. Strain is equal to extension over original length, and then we can change it like this. When we times, we swap these two places, original length over extension is equal to force applied. We can use here 5.4 times original length, which is 3.2 meters, divided by (0.4) cross-sectional area. Remember to change millimeters squared to meters, which is -6 times 0.06. See the 0.06 and 5.4 we get from the graph. Here we use this one, 6 and 5.4. And let me use the calculator. We get the answer to be 7.2 times 10 to the power of 8 is pascals. Okay, this one, determine an estimate of the work done on the sample as it is extended from 0 extension to its breaking point. Explain your reasoning. Okay, so we know the work done is equal to area under the graph. It said estimate, so for the curve part, we can just do this. We can draw a line here. And then we treat, it's not straight, but we can treat it as a triangle. Ends here, all the way down. So 200 minus 160 divided by 10. So one box is 4. So here is 192 millimeters. So down here we have a big trapezium and a triangle. So we find the area of the trapezium first. So here is A, B. The formula for area of trapezium is A plus B divided by 2 times the height. So A is 192 plus B. B is straight line down is 60. So 192 minus 192 divided by A minus 60 is 132. Times the height is 5.4 newtons. I'm going to do the calculations here so it's like easier, so you don't have to flip. Okay, hold up, let me use the calculator. So we got 0.875. Oh yeah, during calculations, don't like premature. Round off. Write as many SF as you can. Then this triangle here, 102 times the height of the triangle, which is, okay, where is X? X is here, so six point six. So 6.6 minus 5.4. One triangle area is 1/2 times base times height. Base of the triangle is we found just now. Calculator time. .0792. Alright. So we just add those two together, then we got the work done. So 0.0792 plus 0.8748. Which is 0.954 joules. Okay, so quick note here that the mark scheme, because it's estimation, they allow 1.0 plus minus 0.2. So your answer can be anywhere between 1.2 to 0.8. It's alright. There's a range of accepted answers. Second sample of the same material and a larger cross-sectional area than the original sample but the same initial length. The two samples are each deformed with the limit of proportionality. State and explain qualitatively how the spin constant of the second sample compares of that of the original sample. Okay, so you know that f is kx and k is equal to f over x. And then from the Young modulus equations now, f times original length over area times extension. So we can sub the k inside actually. So the k is f(x). So k times original length divided by the area. Okay, so now this is constant. They say it's the same material. Area is larger. The length is also constant, the same initial length. So what would happen to k if area is increased? Since this 2 is constant, A is proportional to k. So if k increase, A would increase also. I mean, if the area increase, the constant would increase. So we can say that the k will be greater on the second sample. That's 1 mark. I just double check and you have to explain. It is because k is proportional to the area. Make sure you write spin constant, right? Don't put k. Just be safe. Okay, let's go. 12 marks. Not too bad, not too bad. I mean, if you find it a bit confusing, you can ask any questions in the comments. I will answer you, because I feel like my explanation is like not really clear. My apologies. Alright, question 4, waves. Let me show you. So R and T are points of the wave. State the phase difference. Let me show you a quick and simple way to find the phase difference. So from here, from point R back to the equilibrium, is 1/4 of a period. So because here all the way here back to here is 1 period. So here to here is half a period, and then here back to here is another 1/4 of a period. So all this is you add up all here will be 1 period. So 1/4 period plus half period is equals to period. So we just use 360 degrees times 3/4. Then we can get 270. So the phase difference between R and T is actually 270 degrees. On figure 4.1, draw an arrow at point T to show the direction of movement. So the direction travel of the wave is this way. So from R, all the particles here will be moving like this. And then once it reaches equilibrium, it will move down. So particle T is actually moving downwards like this. So we know that from here to here is 3/4 lambda, and they give us that 0.62 cm. So we can say it's equals to 0.62. Remember to change it back to meters. So -2. Then we can find lambda this way. So calculate. Now I'm going to write is this one. I'm going to write this one. because we're not done with the question yet. So we know that V is equal to F lambda. Then we want to find frequency is equals to the speed 0.27 divided by the answer just now. So frequency is equal to 32.6, and we can write 33 Hertz to SF. Okay, part D. Wave voltage produced by dipper S1 attached to a vibrator in ripple tank. Another dipper S2 is attached to the same vibrator. Two dippers produce an interference pattern on water in the tank. Okay, since they are attached to the same vibrator, we can say that they have constant phase difference. And you see here, in P, trough meet with a peak, and then it will cancel out. Okay, crest meet with a trough, and then they will cancel out. Okay, so first point there's three marks, so we have to give 3 points. So first point, we can say resultant is sum of the displacement of waves from S1 and S2. Second point, at point P, waves from two sources destructively interfere. The third point, amplitude. Conclusion is the amplitude at P of resultant wave at P is 0 at all times. Okay, done with wave questions, so 8 marks. Alright, question 5. State Kirchhoff's second law. Kirchhoff's second law states that the sum of the EMF in a closed loop is equal to potential difference in a closed loop. Say the conservation law that gives rise to Kirchhoff's second law. Now energy cannot be created or destroyed, so law of conservation of energy. Okay, a circuit should contain a cell of internal resistance R and two resistors of resistances R1 and R2 as shown. The potential difference across the two resistors is V, the current in the cell is I. So we have to show that the total resistance of the external circuit is given by this. So I will split into I1 and I2, and now by Kirchhoff's first law, Kirchhoff's first law, I is equals to I1 plus I2, and they say that the voltage is same across R1 and R2. So Ohm's law states that V equals IR total. So I equals to V over R total, and then we can say that I1 equals V over R1, I2 equals to V over R2. This implies that. So V over R equals to V over R1 plus V over R2. Now we factorize the V. This one and this one will cancel. Then we get 1 over R equals to, total equals to 1 over R1 plus 1 over R2. Shown. Okay, the EMF of the cell is 1.5 volt, and the values of R1 and R2 are 10 and 15 ohms respectively. The potential difference measured by the voltmeter is 1.38 volts. So now we have to find the internal resistance R of the cell. So first we find we combine these parallel resistors, and we find what is the resistance. So we use this formula. 1 over R parallel is equals to 1 over 10 plus 1 over 15. And we can inverse this like this. Power of -1. And then using a calculator we will get 6 ohms. So we can find the current from V equals IR. So I equals to, so the voltage, the voltmeter measures 1.38 divided by resistance 6, and we get 0.23 amperes. Now we can use the internal resistance formula. EMF minus V over the current. Okay, now R equals EMF is 1.5 minus V 1.38 divided by the current we found, 0.23. R equals to 0.52 ohm. Okay, so a third resistor is added in parallel with R1 and R2 in the circuit. State and explain the effect, if any, of this change on the current in the cell. So if the numbers of resistor is increased, then the effective resistance will decrease. So I is equals to the EMF divided by resistance total. So when the resistance is decreased, the current in the cell will increase. So total when the total resistance decrease while EMF is unchanged, so EMF is constant, the current in the cell will increase. Okay, so part 2, the potential difference measured by the voltmeter. So in part 1, we found that the current in the cell would increase, so it will cause an increase in the current the increase of the internal resistance, and then while EMF is constant, the voltage will drop. So we can explain it like this: greater current in the cell means more loss volts. So terminal potential difference will decrease. Okay, question 6. Nuclei of an isotope samarium each contains 62 protons and 85 neutrons. So state the nuclide notation in the form like this for this isotope. So we write SM. So the 1A will be the nucleon number, which is 62 plus 85. Is 147. And Z down here would be proton number, so 62. The isotope of samarium is radioactive and decays by emitting particles. Gamma radiation is not emitted. The energy spectrum of the emitted particles is shown in figure 6.1. So explain how figure 6.1 shows that this isotope of samarium emits alpha particles and does not emit beta particles. So we can see here the kinetic energy of this particle is discrete, meaning it only has one specific value. So we know that alpha particles have only one specific value, and beta particles, however, have a range of kinetic energies. So let's write alpha particle. Energy of alpha. Oh my god, it's 4 AM now. I can't concentrate. Sorry. Energy of alpha particle is discrete. Wow. Energy of beta particles have a range of kinetic energy. So this one cannot be beta. The isotope of samarium decays to an isotope of neodymium. Give the radioactive decay equation for this decay. Include the nucleon and proton numbers of all the particles involved. So first we write down the decay into D plus the alpha particle. So alpha particles, they have two protons and 2 neutrons, so the nucleon number is 4, 2 protons. So the equation has to be balanced because of conservation. So here is 147 minus 4, so it's 143. And then 62 here has to be balanced, so it will be 60 protons here. A baryon is composed of 3 quarks which all have different flavors. The baryon has a charge of 0. 2 of the quarks in the baryon are an up quark and a bottom quark. Determine in terms of the elementary charge E, the quark on the charge on the third quark in the baryon. Alright, finish this and I can go sleep. 4:18 AM now. Last question, let's go. So we know there's an up quark. Up quarks have a charge of positive 2/3. and there's a bottom quark, and bottom quarks have -1/3 charge. And then we have an unknown charge, so I'm going to put it as Q first. And the charge on the baryon has a charge of 0, so equals 0. And then Q equals to -2/3 plus 1/3. And the charge of the third quark will be -1/3 e. State a possible flavor for the third quark in the baryon. Now you can write either down or strange quarks, because these have -1/3 e. And then we are done at 8 marks. So I hope you understand what I said. I know I'm not really clear, especially on the electric part, so if anything you can leave the comments below. I'll try to help you out, or you can hit me on Instagram, Jan_stem1, and I'll try to help you out best to my abilities. Thanks for watching, and thanks for understanding. Bye bye.